We're now going to look at how a Power Analyser and a ScopeCorder receive the same signal and how they both deal with it in different ways. Michael, explain how that works.
Yeah, so for this example we took the switching supply. So on both instruments you can see at the waveform display in yellow the voltage and green the current consumed by the switching power supply. So the Power Analyser is very good in measuring all the numerical values with very high accuracy. However, it has limited waveform analysis capabilities. So if you want to get more detailed understanding of the waveform, that's something that the DL950 can offer. So we can measure here the waveforms with higher sample speed and have access to the raw data so that you can perform additional calculations with it. So again, so in yellow we have the voltage across and the current through the load, which are the instantaneous values. And the other values that you see a bit jumping up and down on the screen.
Yep.
These are the parameters similar to the Power Analysers that are being measured, and they trended over time. So the power, in this case, all values like voltage, current RMS and power are calculated over one input cycle of the signal, and they're being trended over time. Besides having similar capability, although with different accuracy, you can additionally offer also all kinds of signals and parameters.
So if you're running a project on a Power Analyser, you're saying that this ScopeCorder can do exactly the same thing this Power Analyser can do, but there are extra things on top of that that it can do too.
Yeah, that's correct. Although it does measure power but with different accuracy, on top of doing this, it can also measure physical parameters like temperature, strain, vibration. It can read in data from serial buses, from CAN bus and LIN bus, for example. So you can also correlate data from a complete system that's captured by other sensors over the CAN bus. You can capture as well. And as there's all functions like on oscilloscopes, you can also trigger on the signals. You can not only trigger on the captured waveforms, but you can also trigger on the numerical calculated data. So when you see that whenever current amplitude is becoming too high, which you expect that's causing some overheating issues or other problems, you can also trigger on the current signals.
Excellent, thank you.